In today's class, I'll be explaining about integral by parts. Here, I'll be explaining about two important techniques. One is ILATE, another is DI method, and this is also known as tabular method. Let me take up first this one. ILATE. First of all, let me consider the integral by parts. Integral u dv is equal to uv minus integral v du, where u is the first function, v is the second function. Now let me consider x squared, integral x squared e power x dx. So here you can find two functions. The x squared is taken as u and e power x dx is taken as dv. So we have to differentiate this u, and in this case we have to integrate this dv. Now let me explain one by one. Which should be taken as u and what is the clue for that? Suppose if you have inverse trigonometric function, you can take the inverse trigonometric function as u. For example, sine inverse x, cos inverse x, etc. If you have logarithmic function, you can consider this as the either it is log to the base 10 or natural log. That is taken as the u. And if you got algebraic function, so that should be taken as u. So algebraic function. So it may be x squared or x power 1 by 2, that is root of x. And if you have got trigonometric function, that can be given preference. For example, sin x, cos x. Then if you have got exponential function like e power x or 2 power x, etc. So in this order we have to give importance for the first function. Now let us proceed with the integration, and in this case I will try to explain the DI method also. DI method, this is nothing but tabular method. Now let me consider integral u dv. So uv minus integral v du. This is the strategy. Now listen, you can put the sign here, and this is the derivative, that is differential function. and these are the integrals. Okay, so the first thing is we start with plus here. This is the plus sign, so we start with plus, and in the first case you will have u, is it not? And this is dv. Okay, in the next step you have to put the minus sign, and that indicates the second value. And if it is minus, now you have to differentiate this, first order differentiation, and this is the first integration, first level integration, and put plus, and this is the second order differentiation, and here second level integration. Likewise put minus, and this is third order differentiation, here third level integration. So likewise it goes. So this is the strategy I will try to explain based on a sum. Let us consider the problem x cube y is equal to x cube sin x then dx. Now let us follow the strategy. So this is the algebraic function and this is the trigonometric function. So which is the priority? Algebraic is the priority and followed by sine. So we have to give u, the first function, as x squared, in this case x cube. So let us have x cube as u. And what about this? This should be taken as dv, right? Now let us proceed with the di table. This is differentiation, that is derivative, and this is integration. So let us start with the plus. So sine, and this is differentiation, integration. Start with plus sign, that is plus, and what is the formula? That is integral u dv is equal to plus uv minus integral v du. Okay, so this plus is represented here, and we have u. What is this u? X cube. And what is this dv? Sin x dx, is it not? So sin x. Now we are going to integrate this one and differentiate this one. Put minus sign here, and what is the differentiation? 3x squared. Differentiation of x cube is 3x squared. Put plus and further proceed with subsequent differentiation. So first order differentiation. Now let us proceed with the second order differentiation. 3 2s are 6x. Now let us proceed with the third order. So we have to put minus here, and this is 6. Now let us further proceed, and this becomes 0, being a constant. We can stop with that. Now here sin x. What is the integral of sin x dx? This is minus cos x. What is the integral of minus cos x? You have got already minus, and this is sin x. And what is the integral of minus of sin x? Minus of minus plus cos x, correct? Okay, and then what is the integral of cos x? Again sin x, right? Now let us proceed. Okay, so what we are supposed to do, we have to start like this, uv, is it not? So u and this is v, so we can put like this, take this plus and proceed with this. Okay, so you are able to get the value plus x cube into minus cos x, is it not? So minus x cube cos x, this is the first term, and we have to proceed with the second term, minus, because this is minus, so put a diagonal like this. Now let us proceed. You got minus and already minus, so minus of minus plus, and 3x squared sin x, are able to follow? And then now proceed with plus. Okay, so you can take this, now plus 6x, okay, into cos x, right? Now let us proceed further. This is minus, so 6 sin x, is it not? So minus 6 sin x, so minus 6 sin x, and then it is 0, so it becomes 0, so this is constant, so you can put plus c, so this is the answer. Are you able to follow? Okay, got it? Right. Now let us proceed with another sum. Okay, another example. Let us consider x squared e power x dx. Okay, now let us apply the strategy here. We should be taken as u here, so the u algebraic x squared followed by exponential, so u is x squared here, so consider this as u and this as dv, right? Now what is the formula? u dv, that is vu minus integral, you can put either uv or vu, so minus v du. Okay, right. Now let us proceed. Sine, and this is different derivative, and this is integral. Okay, so start with plus, and plus, what is the u value? X squared, and what is the dv function? E power x dx. Okay, now let us proceed. Minus, this is 2x. What about this? This is e power x. Okay, and plus, and this becomes 2. Here again e power x, minus, and this becomes 0. Okay, so you cannot proceed. Now see, integral x squared e power x dx is equal to, now plus uv, that is x squared e power x, and then minus, okay, so minus 2x e power x, and then minus, that is plus 2 e power x, after that constant. Okay, right. Now let us proceed with another sum. Let us consider integrate sine 4x of e power 5x dx. Okay, now according to this, that is, we have got this ILATE method. According to this, we have got trigonometry and exponential. So in that case, trigonometric function should be given as the first function. Preference is given to trigonometry. So u is equal to sine 4x, and this is dv. Now what is the formula? U dv is equal to uv minus integral v du. Now let us proceed with the tabular method. So this is the sine differentiation I, so di method, plus minus plus minus plus, so you can proceed like this. Now what is u here? Sine 4x. And what about dv? E power 5x dx. Now let us proceed with differentiation. Now sine 4x, it becomes 4 cos 4x on differentiation. Again cos minus sine, so 4 4s are 16, so minus 16 sine 4x. Again 16 into 4, 64, so minus 64, and sine 4x cos 4x. Again we have to integrate, differentiate. So here you can multiply these two, so cos becomes minus, so minus or minus plus, therefore 256 sine 4x. Similarly, we had to proceed with integration. Now e power 5x dx, on integration we get e power ax means 1 by a into e power ax. So 1 by 5 e power 5x. Again 1 by 5 into 1 by 5, 1 by 25 e power 5x. Again integration, so 525 125 e power 5x. Again that is 1 by 625, then e power 5x. So it means it is never ending, it is going on. So the best way is using the y function, we can try to do the circular integration. Now let us proceed. Integral sine 4x e power 5x dx is equal to, now let us proceed like this, plus, okay, so uv sine 4x into 1 by 5 e power 5x, okay, and then minus, why we got this minus, right? So let us proceed. Minus 4 cos 4x, and then here into 1 by 25 e power 5x. Again, now let us proceed further. Before that, let me rewrite this sine 4x e power 5x into dx. So this is taken as I1. So let me proceed this. I1 is equal to, so let me repeat, sine 4x 1 by 5 e power 5x minus 4 cos 4x 1 by 25 e power 5x. Now we had to proceed and look at this here. So we had to put plus and then proceed, and we have to proceed like this, but we cannot take this because we are going to retain this as, that is, this is v u dv as such. Okay, so we are not going to further integrate it. Instead we are going to replace with I1. So we should not go diagonally like this as we had done earlier. So therefore you can put minus 16 sine 4x into, and don't proceed with the 1 by 25, instead you stop here because we are going to retain this as integral only. So 1 by 25 e power 5x, put dx. Now this is u dv, this is v du, this is the integral, is it not? We can put like this. So this is, let me take a 16 by 25 outside the integral. So it becomes I1 is equal to sine 4x into 1 by 5 e power 5x minus 4 cos 4x into 1 by 25 e power 5x, and put here 16 by 25 taken outside the integral. Okay, so it becomes sine 4x of e power 5x dx. Okay, this is nothing but our I1, is it not? So we can comfortably replace this by I1. Okay, you can call this as I1. So this can be taken to the LHS. Therefore I1, that is 16 by, you have got already I1. Okay, now plus minus I1, minus 16 by 25 I1 becomes plus 16 by 25 I1, is it not? That is equal to the remaining LHS, sine 4x by 5 into e power 5x minus 4 by 25 into cos 4x e power 5x. Okay, now so this I1 can be taken outside the bracket, so this becomes I1 of 1 plus 16 by 25. So that is taken as LCM. So 25 plus 16 divided by 25 is equal to the remaining term, that is sine 4x divided by 5 into e power 5x minus 4 by 25 cos 4x e power 5x. Got it? Right. Now this is 41 by 25. That can be reciprocated on the other side. Therefore I1 is equal to, that is 25 divided by 41, open the bracket, sine 4x divided by 5 e power 5x minus 4 by 25 cos 4x e power 5x. Okay, so otherwise you can write like this, 25 e power 5x divided by 41, open the bracket, then sine 4x divided by 5 minus 4 by 25 cos 4x. Okay, this can further be reduced as 25 by 41 e power 5x, open the bracket. Now this is LCM 25, so this is 5 times, so 5 sine 4x minus 4 cos 4x. Okay, so that is equal to, now this 25 can be cancelled, therefore e power 5x divided by 41, open the bracket, 5 sine 4x minus 4 cos 4x, and this is the final answer. Got it?